So, Andrew, the stage is yours. So,
Okay.
thank you very much for coming. We are, as I told you, we are the health mission. And our main goal is promoting the quality in healthcare services. So we want to develop some standards, we want to develop some guidelines, and we want to create some kind of models and to disseminate them in order to promote the quality of healthcare services. So we are very interested in your work. And we expect to include your work in our future seminars and maybe courses. So this is our objectives. Okay.
Fantastic. Thank you. Thank you for the
Thank you
opportunity.
so much. Thank you so much. Okay.
Can you guys hear me okay?
Yes, you can start when you want.
Okay. Sounds good. I have my screen is showing right now the paper that we published. So I want to start by showing that all this conversation is going to be about this paper and the tool in the sandbox environment that we used. It was a team effort. I'm the lead author for that, but is all these people that were members of the AMIA, the American Medical Informatics Association, the CDS work group. We got together to put these tools together because we will go to a presentation and see one piece. Then you go to another presentation, see another piece, but you don't know how they are connected, how you can start and finish. So this tool allowed us to start and finish a clinical decision support with all these open source technologies. And before I keep going, so my name is Andre Soares. I'm associate professor in the School of Medicine at the University of Colorado. I was born in Brazil and I speak Portuguese. Brazilian Portuguese.
Wow!
Sim, eu falo português.
This is quite interesting.
Okay. So one thing that I want to make clear is that the information that's been presented is not reflecting the institutions that are behind each of these participants. So it's our idea, our project to put these things together. It's not AHRQ or Maitri or some other institutions that are involved in this, or my university, University of Colorado. Okay, so this is the idea of the paper. We create, I'm going to go show one piece here that's very interesting. It is, the goal of this is to go through these 7 items using FHIR as the the source of data for health. Today, EHRs have the APIs for providing FHIR resources, so we can use from that. We can altering logic to process that data, so creates clinical decision support. For this specific process, we show how to use a tool to do that and how to use to also write things by hand. We translate the code. We create a smart on fire applications. One is presented in this tool, but after this, I have been involved in developing smart on fire that integrate with EHR systems. And we have the service and the CS hook, which is triggering as a mechanism to trigger information when some information about the patient is available. So we're going to see that. So this, we presented this twice at the AMIA symposium. One was, we asked the participants to install on their computer. Didn't go so well because everybody have different computers, different memory, different approach. So for the second approach, our team decided to go and put this in the cloud. So what we did was get the tool, put in Amazon AWS, and create one instance of this, test everything works. Then you have participants for the event. I just went there a day before and I create 50 copies of that instance so that each participant could have their own environment running for testing during the workshop. That worked much, much better. And there's no time waiting for installing this. Everything is running on the web. They just need to go from their computer, access the web, and using the system. So enough about this. I'm going to come back here. One more thing in here is, what is that? The companion material for this workshop is we have the tutorial. This tutorial, it shows step by step. You have all the steps. Once you're in the system, what you do with that. It shows all the components, how you create the logic, and how you make that usable. So the component is, internally, the system has several servers, mini Docker containers running applications, and the system needs to access outside to go to the VSEC, which is the value set authority center, to get codes. And we do the authoring tool inside, but we need the logic coming from outside. The whole system was for this study case. As you're moving forward, you can create other study cases that people can learn from this. It was for using statin, that have the inclusion criteria, exclusion criteria, and a recommendation. So this is available on the website. So we have the publication, and in the publication we have here the supplemental material, and you have this document. So it's available online. So, and we'll go step by step how to do these things. I'm going to come back here later. Now I want to show you this. This is, I'm remotely connecting to the instance that's running on AWS. This system was 2001, so I haven't used it a lot since then. I have used the tools, but not this environment. So since I talked to Mario, I put together and was able to get everything up and running again. So the participant would come here and have this system. So now I'm going to go to different tools so you can see what this can do. And what's very valuable, because we had technical people, health people in the same room discussing things, because it's not too technical. We're going to see some tools that they are easy to implement things, and they can discuss the problem and not the technology. So let's see. Like I said before, there are several components here. I'm going to go one by one. So the first one is a web page. Not too much. It has a CDS authoring tool. This authoring tool was created by Maitri. It has been discontinued for now, and now there is a community edition that is free. You can go to the GitHub, install to your system. This tool is used for creating the CQL logic for processing the data. Then we have services. And these are simulating what the EHR system would do. So here in our institution, we have Epic. Epic has this component, so you can play with the logic, knowing that this service, this fire, they're going to be there for you. So you can concentrate on designing applications, testing the logic, and so on. The next one is the CDS hooks, which is used in this example. Once you've seen the patient, there is these things called cards. It's a alert. This patient, based on the conditions, this patient has this information. We're going to show that by doing some of the work, if you see a patient and there is something in the chart, it processes and say, oh, this patient would be due, you can say, due for a screening. This patient should use this medication, and you have some ways to alert the doctor on this. That is, I'm going to show an example is converting SQL to be usable. I'll explain more on that. This is a small Smart on Fire application. Smart is the technology that is used to access the Fire APIs. We have right now implemented in our system, we working on the system that we create a Smart on Fire. It runs inside the EHR screen and talks to the Fire so we can get data, process, and have an application run within the chart. And here, it's simulating, it's using an EHR simulator. You can pick one of the patients. It processes. The one is spinning. What is doing one few things. Goes to the Fire, grabs all the patient data. So in this case, this patient has 109 resources. Reads the logic of the SQL file, which in this case is the condition and medication. Oh, by the way, it's too small. Let's see if we can make it bigger. If it's still hard to see, let me know. I'm going to talk about this application. And that's what we do right now. We create applications that can talk to Fire, process the logic, and be used for different things. And the important here, all this in this environment. So we're simulating everything that a person would see in other systems. They can play with the parts that they can create applications for patient care. Here we have a happy file. Is a server with patient data. So in this case, you can see here, patient 644 patients there. It's all synthetic data, but because it's an environment where they can play with, I do for other projects, I create patients with specific conditions. This patient, I create a history of the patient. This patient is taking medication, had a surgery. We can tell the story and upload the patient here so we can test the logic with different cases. Because it's hard to go back and then do that in the HR, but you can simulate the patient in here to do that. So we have a bunch of patients to use. This Smart App Launcher is a similar, like I mentioned, in the EHR, we have application that runs inside the EHR system. This is doing the simulation for that. I can say, I have this Smart on Fire application on this location at some URL, and the system does the communication with Fire and makes the connection. And all these tools are free, open source. For this project, we use the Fire R4 version, but you also have the Fire version 3, Fire version 2 for this. So I'm going to stop there and say, we look all these tools separated. We understand how they worked, but we didn't know exactly how the big picture, how these things work together. So the goal for this project was, let's see, I want to create a clinical decision support application. What do I need to do? How can I start? So now that you know we have all these tools, I'm going to give you an overview of how we did the process. That's the important part. So I'm going to start with the CDS authoring tool, which is, I have a logic. I want, if the patient has this condition, is on this medication, has a lab result of that, I want to do something. In this case, I want to recommend something for the user. What's going on? Frozen. I'm going to disconnect the interface and come back just a second. It's kind of slow. Oh, it's back. Okay, so in this interface, you can create a new artifact. So have a logic. And I'm just going to go through some steps. This whole workshop took 3 hours, so I'm not going to do that. I'm just going to show the pieces so you can see what it is. The first one is creating an artifact. So let's say starting version 1.0.0. Oh, come on. And the interesting part of this tool is that it's friendly. Writing CQL is not very easy, but if you have the logic, if you understand what you want to do, this tool could help you to get there. It was created by Maitri, and they make things very easy to do. You have an inclusion. So one simple inclusion. I want patients with an age between 40 and 75. So you go to demographics. You want the age range. Age between 40 and 75 in years. Every logic should return a Boolean. So if the patient is within this, true or false, then the system can process that. And we also want a patient, let's see, second. Want a quick example from the material. But yeah, I want an observation. Here's the part that's interesting. To look for observation, you need to know the code, right? What is the line code for the observation that you're looking for? Here, this tool allows you to connect to the VSEC, which is the Value Set Authority Center. I'm going to grab my API key quickly. In connect, it asks for an API key. This is from UMLS. You can go online and create that. You can use MLS if you want to access Snowmed. You use the VSEC and some other tools from NLM. Now that I'm here, I can go and look for LDL. This app does API calls to the value set authority and say, hey, here's the list, all the lists with ADL, what one you're looking for. I'm looking to ones particularly, it has 19 codes. I can click here and see the codes. Then you can go inspect. Yep. These are line codes. I'm a computer scientist, so I'm not a doctor, but a person will go here and say, yep, I understand, and this is the codes that I want. Select. So this is still not a Boolean, true or false. We need to make some adjustments to this. So the first adjustment, first we're going to say, I want LDL. I'm going to name this as LDL greater than milligrams for deciliter, I think. And I'm going to add some modifiers. I want to get LDL for the last 6 years. So I'm going to say look back for 6 years. I want verified results. I want to look the most recent in the last 6 years. And I want a quantity of greater than 130 mg milligram per deciliter. Okay, I'm gonna add this logic. So now this logic is okay. It has a Boolean, so the system can do a check, and it has. That's the part that was interesting during the workshop because you're doing this tool. You have a clear text explain what's doing, so you can talk to someone that's not technical. And the important thing is behind the scenes is converting all that into CQL, clinical quality language code. And you can do other, so here would be the inclusion. You can do grouping. I'm just going to show quickly. I'm going to do a group of LDL is part of a group that's one or more risks. So the patient can have LDL high or the patient might have diabetes. So I'm going to go to conditions. Look for diabetes. I'm looking for the 777 codes within that group. I know that's the one I'm looking for. I'm going to pick this one. And I want here, I'm going to add some modifiers. And now we're going to be more specific. I want to say, for version 4, I want to say the verification status of the condition must match one specific code, must be confirmed. So different ways to make the check. This verification status is in the file structure. You have these data elements. One element is, I think it's better I can show that. So in the file structure, we have resources. File has a bunch of resources. So I'm looking at the condition resource right now. The condition resource says this structure here. In the verification status, these are the codes that can be used for that. So I'm telling the system, get the patient observation, check for the verification status data element, and see if it's one of these items. I'm also going to look at the clinical status that's binding by this set of value sets. So I'm using Fire to do that. So one would be this, and the next one would be, I also want the clinical status to match a code from the file structure that says that it's active. The patient has that condition right now. And I don't have a Boolean yet, so I'm going to say, I need to say, I don't know, I don't care when it happened, I just want, do you have that information? So I want to say, if exists information that there exists a condition with a code from diabetes, from that list of 700 codes, and the verification starts like this, I want to know. So I'm going to stop here. You can do more things. You can say, and you have, for this example, we have say, these are the inclusion criteria. I want the patients that meet this inclusion, but I want exclusion criteria that says, if the patient is already taking statin, I don't need to suggest statin because the patient is already there. So I could create a exclusion, go to the medication request, look for statin, and then pick one of the codes that has a different medications here. So just for this example, and I say, you can do other things here. And the other thing we do here is, if the patient passes the inclusion, does not pass the exclusion, so the patient should be in this approach, this application allows you to create recommendations. So I'm going to key quickly. Here's one example we used for this. I'm going to copy. Say, if the patient passed the inclusion, didn't pass the exclusion, the patient should start low to moderate statin, moderately intensity lipid lowering therapy. So then you can say, that's the logic behind things. So pretty easy. You have a tool that can do things for you. It's not complete, of course. There is errors. You can see that, but I want to show you. All that behind the scenes is creating this. What you see here is CQL code, clinical query language code. So it has a library statin that we created. It has the address for the value sets from the VSEC. So when it's time to do the logic, it knows exactly where to get that list of big codes. We define the age. So here it is, the age 40 to 75. The LDL, we have a quantitative value, the most recent verified observation of LDC in the last 6 years that's greater than 130. The patient exists a condition of diabetes where the verification status is confirmed and the clinical status is active. So all that work is to create this. So the CQL is the language that's used for the logic, and the tool makes very easy to start because you click, once you get used to that, it's easy to do. Once you've done that, you download and that can be used. So I'm going to stop here because I'm not going to do the whole process, but I want to show this. I downloaded I did that previously. So I download the file. So everything comes back as a zip file. When I go here, it has all the components that you need to test that logic, to run the logic. The sample file is here. Oops. It has the same logic here. So in that, the thing that we do in the system, the next thing we do in the system is to show that you can use the tool to start. So if you work with a doctor that's not technical, they can help you go through things. But sometimes the tool may not be able to do what you want to do, has not the features for that. You can come here and write your own code. So I'm going to show an example here. I can say, oh, I want to add this value set here for hypertension. Well, make it bigger. Okay, so I can write code. And one more example here. we're doing the diabetes, and now you want to do the hypertension as well. So that's the part that's interesting, because you can write code, or you can use the tool to write the code, to generate the code, but you can also come here and supplement the code with additional information if the tool cannot do it, or if you prefer to use a text editor to do that. Now I also want to check if the patient has hypertension, and I'm gonna do one more thing, say one more risk, diabetes, or has hypertension. Once this is done, let's see if I have, yeah, that's it. So the idea is, for this environment, you can bring some expert health professional that has the ideas what to do. You can work with them one-on-one doing the tool. If for some reason is necessary to go more in depth, you can just write the code, which is CQL. It's a standard developed by HL7. So when this is done, you can go in you can translate that. So you can say, because I changed the file, if you look in the screen here, the file starting use example has 3 versions: CQL version with the logic, JSON code, which is a compilation to convert it from CQL to ELM, and it can also be converted to XML. So here I'm just going to say, go to this folder in I'm not there. A second. Need to put all this. In here. So once you're doing by hand, you should be able to tell the system, translate the code, and do that. So any modifications, the code can be done by hand. So it's a team effort, right? You have the health professional, you have the technical person. If it needs to go down and do some code, you can do and still have the system ready to go. So one last thing. So now I have this system up and running. Let me show you. Then the next thing is, how can I test this? We have the patients. We have the CQL results. I can say, let's run Jeffrey. Here is running the condition medication application, but I want to test the new one. So I need to do one small change. I'm going to go back to here. Copy the name of the library. I want the system to test this logic, not the other one. So I'm saying, I want to test Geoffrey with that logic now. So now the system goes, grabs the new patient data, processes the new file logic, and we know this patient is not in the age, doesn't have diabetes, so this patient not pass the logic for this. But I know a patient called Miles that would pass this. I'm showing, let's see how I'm doing. I'm showing the different components because the person that was sitting in the workshop is someone that is interested in doing things, but they want to know what else do I need to do. Some of these things, the HR is already implementing, so you don't have to do. But because of that, you can simulate everything outside. You can create the entire application, you can create the entire logic for clinical decision support, test. And once tested here, then you can go and talk to the HR IT team and say, how can we implement this in production within the system? So if I use Miles here, I have two details here. I know Miles would be a candidate would be recommended. I'm using the right tool, but I don't have any data. That is because that value set, all the codes needs to be here so that I can use that code to test the logic. I need to do. So from here, what's happening is I'm going to show you this file is empty. So what I want to do is and all that needs to be done. So if you create an application for production, all these pieces needs to be done. And that's why we're careful to show that, because sometimes you think about, I want this solution, but you don't know how much work goes into things, and that was important to show. So in this case, the system uploaded 11 value sets for all the system that needs to be done. If I go back to this file, you went back there and say, oh, for this value set, here's the list of codes. And you can see here all the codes that you need to make a decision. Just showing the value set is not enough, so you have to bring all the code here so that you can see the code, the patient with the code 167477 matches this logic, so the patient has diabetes or has LDL high or something. You need to do that. Let's see Miles. Well, Miles has hypertension. It's in population, but in receive a recommendation. Now I know that this patient is good to go. So I create this CQL result just to show the result of the logic, because for some, and you can sit with someone that's not technical and say, oh, I can see, I can open this. Well, not now, but you can open this and see the details without going to the file code. I say that because if you go to here and you want to see a file code, it looks like that, a JSON code. Nobody wants to see that. So that's why I created a tool to show the results in a way that's easy to see. Well, there we're showing the results of the logic, not the results of file. But anyways, we create the application because we don't want to navigate through this, talk to a doctor, talk to health providers, but we can show exactly what's important. So now this system is done. The logic is tested. I'm happy with that. I'm skipping some steps here, but the next step would be make this available, load to the system. It is a hook, so it can be triggered, and I have the library that we just created uploaded to the system. Now the EHR simulator can use our own logic, and you can test to see if it's working correctly. So from here, to test that, we can go to, I'm going to go here, load patient number 1. It's just the card for greeting is loaded. I'm going to load Miles. Let me check one thing. Okay, so now what we do is we go back to the here, we grab the address for these services. Oops, back to Miles. Okay, Miles is here. The system is not available yet, so nothing happening. If I add this new service to the system, and that happens in the HR, you could implement that. This is just a simulator. The system is going to go grab the patient data, process and say, oh, this patient has this condition of medication. He would be recommended this. So the system is triggering the logic for the patient, for the doctor to talk to the patient. So this is showing is a provider-facing app that's helping the provider to communicate something important. So here, the logic generates this card as a reminding the doctor to start the medication, and create a card with a link to a decision aid to start talking about statin. That covers the tutorial in a very short time with all the pieces. But the idea is we use all open source. Fire is in US is used by HR systems. CQL logic is supported. Launching application is part of the HR, and triggering things is part of the HR. So I'm going to stop there and see if there is any questions about this, the technology, the tools, how we did it.
Okay, thank you. Any questions from you? Fernando Duarte, I think that you are from IT departments, right?
Yes, I'm from the software development team.
A software development team. What do you think about this?
I think it's very interesting. I think the biggest problem here was that we don't have the database of our patients in Fire as today. I think it's a problem. I think we are going in that way, but we're still far away from that. I think was the biggest problem. We have a lot of data, not extracted as the Fire, so we can. I think it's very interesting for me. Is the authoring tool give
very user friendly? I think that the authoring tool is very user friendly.
Yes, we can give them to the end users, and the end users create the logic from CDS.
Facts, yeah, exactly.
Yes.
Yes.
After that, I think the other service, in our specific case, we will need to create all the tools, not to connect to Fire to get the data from our database, from our structure, and then apply the same logic as these tools apply to the Fire database. or we can start to move or put some data in the FHIR database.
I agree with you. That's our main issue.
That's a good direction to go, because if you in FHIR, then you have more interoperability. You should be able, in theory, to communicate with other institutions because they all talk FHIR. So imagine a patient going to one hospital, but they have data in 3 different hospitals. Then you can ask FHIR data and combine, and so you can have a more round view of the patient from data from different institutions. That's one example of why this is so valuable.
Yes, I'm very known of that, but in Portugal, as today, the things, if you say that you use FHIR, you have a FHIR database, your value sets are completely different from our value sets. LOINC isn't a reality as today as hospitals, for example. SNOMED a little bit in some little resources, and everyone has one code, everyone has their code, and interoperability turns difficult on this way. Nowadays, SPMS has releasing some of the structure of the interoperability, and we are already starting in this path, but I think we are just starting.
A quick question about the health data in Portugal. Is each institution, they have their own data, or Portugal has a unique data for the whole country?
Big question.
I'm asking because in Brazil there is a Serviço Único de Saúde, that all the data from the SUS, that data is in one place, and then I think they're creating a Rede Nacional de Dados em Saúde, where it has an interface in FHIR so that different institutions can do that. I don't know. I'm just asking because I'm curious. I'm not familiar with it.
Here we are just starting.
Okay, good.
We already installed the FHIR server in some institutions.
Okay, fantastic. It's a good step.
Yes.
Okay. I think that Luis may have more or less the same opinion, right? Luis, I think you...
Yes.
More or less the same opinion. There is another dimension. Maybe Olga, are you with us, Olga? Olga is from a very important institution.
Yes, I'm here.
Yes, you are from a very important institution, which is the institution that audits all services, right, Olga?
Not really
Not
audit.
exactly.
We regulate with I'm from the health authority in Portugal, and we regulate all the institutions relating to care, to healthcare, and we don't audit. We have the attribution to make fiscalizations, which is something a little bit different, and we are responsible for the license of the health providers, for guarantee the rights of all the citizens. It means we are responsible. All the claims they are written to the providers came to us to analyze. We make studies. We have now also a new attribution, which means the radio protection. We also are responsible now to give the license to all the equipments that in any way have ionization radiations. and we regulate all kinds of providers. It means public, private, cooperative, military, social. It means a lot of entities in Portugal, and only in Portugal. So of course we are the only entity that has this attribution of regulation and fiscalization in Portugal, and we have a lot of work to do in that area, of course. And we are, which is quite important, we are independent. We have no dependence in any way from the health ministry in Portugal.
Okay, nice. And I think that we can use artifacts in another dimension. I mean, we can use artifacts to measure the quality of the services, right? Are you with me? Do you agree with me? Equality measure. Okay. So I think that this can be very important to health regulators, because we can use these artifacts to create some alerts or to create some information about potential adverse events. And we can use these artifacts to detect some lacks, some things that are not right. Can you say something about this? How this can be used in order to detect adverse events? Okay.
Yeah, I'm thinking about I use FHIR because that's how it's being implemented in US, but the CQL allows you to use different data models. So if you have different ways to get the data, you still can use the tools to do the logic. So it doesn't need to be FHIR. FHIR, it's for convenience to us, but
CQL. I think that we can use CQL to detect adverse events and to create and to send some information to the health regulators, for instance. Okay.
Yes, it's used that way in here. There is an institution for EQCM for quality measurement.
Exactly.
And they use CQL for processing and checking quality as well. I'm not sure if it's all based on FHIR, but like I said, CQL allows you to work with different data models, so it could expand and then still do quality measures with using the same tools, pointing to different data sources.
Yes. Olga, I think that this can be very important to you too, okay? Because of this the different application, okay?
Yes.
Okay, we have two physicians with us. I would like to ask Rui, what do you think about this for newborn babies?
Well, I am a neonatologist and a pediatrician, and I do neonatal intensive care. In Portugal, we have already some, I don't know, CQL-like guidelines on paper. And it's like the American Pediatric Association guidelines. So it would be interesting to translate them into CQL, and maybe one day have that in the computer so that we can use not always going after the text, the PDF. So I think it's important. But our neonatology, I think, has already a good base to start with, because the paper, I don't know if you can call it that way, but the paper CQL is already initiated. It's not a real CQL, it's a guideline, so we can have some points to work with.
Yeah, that's a good step, because you have a guideline, you translate into the logic in CQL, so the system can process that. Yep, fantastic.
Fantastic. And what about the authoring tool? What do you think about the authoring tool? Is it user-friendly?
For me, I think it would be user-friendly with a lot of help. Yes, because we are not very used to
user-friendly with a lot of help. Okay.
But I think it could be manageable. Yes, yes, I think it could be managed. Yes, I think. We need to get in touch with the logic, the logical organization, and then I think we can build something around that. I think so. Yeah.
I suppose that your next question will be, how can we integrate this with our electronic medical system? And I think this should be your next question. André, what can you say about this? Is it possible? Is it easy to integrate this with any electronic medical system?
Well, I don't know how it's done, because here we have the different institutions, different EHR systems, and they work on that and provide the service to us. So some of the tools that I showed you is already implemented by the EHR system. But if you think about other countries in Europe and South America, they actually building this integrated with the system. So I would have to look into how they're implementing to see what's the effort for that. At some point I can say, oh, we're spoiled because the system was done already.
Yes, but I suppose that you have an interface with web services or something that like that will promote this kind of integration, right?
That's how I would expect it to work. Yeah,
yes.
You have an API interface. You have a mapping from your data into the FHIR is not a database. In for example, if here it's a it's an API interface. You ask the API, you want some data. The API transforms the request into SQL or whatever languages it is, goes to the database, grabs the data, converts back into FHIR format, and sends the response. So it's a proxy, is not actually a database. You don't have a database for FHIR, you have a database somewhere, and FHIR translates the calls. So it'd be part of the effort to make sure that your database can be translated into the FHIR format so that it can answer the question, if that's the goal. But it could be other directions as well, because like I said, there are other data models that could be applied. I haven't used them, but knowing SQL, I know that other data models can be used.
Should be feasible, I'm sure of that. Okay, we have another physician with us. Walter, what do you think about this? How useful can this be to your
in our reality? So good afternoon. Thank you very much for your presentation. It was really clear, and I think the images that you put on the screen did help us to understand exactly all the process. I believe that's very important. I'm a family physician, and we are developing in Portugal right now several processes to accreditation and certification in quality of the healthcare centers, and I believe it's going to be very useful. I'm not sure. The worry I have after seeing your presentation is the compatibility of of what we are measuring, because I did understand that you have very clear and very from the beginning a very clear vision from what you want to measure and how you do it through all the parts. Here in Portugal, at least at the primary care point of view of medicine, it's not so clear. Many times you have different subjects, and there is not they are integrated and they are not so easy to measure and also to qualify. But I think this presentation of today is the future that we need in the future. We are trying to develop and working to. So congratulations! It was very useful. Thank you.
Thank you.
Thank you so much.
Yeah, I want to share one thing. I put in the chat a link to the CQL. There is a website with plenty of examples of CQL used, the logic used for measurement and for other things. They're Firebase because, if I'm not mistaken, but I think they have some examples of different data models. I'm not familiar with that. I haven't used it, so don't quote me on that. But you can see the link shows different examples. This website, there is a webinar every month or so that is going through some different aspects of how to use the CQL to calculate this, how to use the CQL to find something else. They're in the session 94, and each session has several examples of how to use the CQL for different parts and definitely for measurement. So that would be a good way to start looking and say, can we do that? Before saying, let's bring our data here to do it.
Okay, thank you so much. More questions? More questions? Do you have more questions? I have one. And how do you solve the problem of having a unique, I suppose that you have a unique repository of artifacts, right? In the United States or in the hospitals. The artifacts,
you mean fire?
Repository. No, I mean the CQL artifacts. So you should have the CQL artifacts archived in somewhere database. How do you solve this? And I suppose that you also have some kind of governance of these artifacts because they have versions.
Yeah.
They have some authentications. How do you solve this?
For one of the projects we have is we create CQL logic for different cases. This CQL, we have a database of these CQL cases, and then we can, in our example, we can approve the CQL case. Say someone revised the logic, is approved. There is a governance. There is an expert that sign off and say, yep, this logic is okay. We tested with some sample patients, and now that is approved, could be used in the system. So we have a database of logics that can be revised,
have a process,
approved, and then if it's approved, they can be used within the system for our specific applications, not for the EHR, for the application that we built. So I think it would be more application specific.
But you have this process inside each hospital, or do you have some kind of national or region service?
I haven't crossed that bridge yet. We create the application because we had a niche or something that we want to explore. We create our own logic, and we implemented at our institution and 3 or 4 partners to see how it will work, but it's definitely not national.
It's not like SNOMED.
No.
It's not national. Okay.
Yeah, I think that would be because the different institutions might have different ways to look at the logic. They want to be more specific. So you might have something that's high level for everybody, but you might copy that and make your own adjustments. Maybe for institution, we're going to look at LDL at 135 instead of 130. So I want to be more customized. So I don't know. I haven't seen a national effort to have those. Well, sorry, there was an effort. HRQ had a repository for CQL files. So everybody that was creating CQL files, they would send to HRQ. They had on the website, you could go into the search and say, someone who's working on this condition, this problem, they upload the CQL file. You could copy, use, and apply to your institution or revise and do something. But HRQ started with the process of generating public repository where people could contribute CQL logic files.
Okay. And I suppose that you have some kind of seal of quality, a quality seal for each artifact, for each CQL artifact. I suppose that you must have
There is a review. The review process goes by different people. Even if in an institution, you have a person that is championing the logic, someone that's creating the logic, someone that's checking that the value sets are appropriate for the logic, to have someone that's checking that the tests were. There is different steps. Is all the way to now it's ready for being put to test. To be used by the institution. So there are different processes. We don't have a certificate or something, but we have the process. We go through these steps up to the point that is approved. And it usually is not us, is the EHR, the institution, that would have someone that would sign off and say, we approve these 2 logic items, but we don't approve these other ones. So it's a working with the EHR. It's not, we build things. We don't put into work unless it's approved.
Okay, good. More questions, please? No? And I do not have more questions too. So
Okay.
Thank you very much for your time. We shall keep in touch. I hope to see you very soon in our next events. And we will have some discussions about our working plan.
Ok, obrigado pela oportunidade para apresentar esse projeto aqui. Espero que vocês, se precisar, estou à disposição para conversar.
Muito obrigado.
Obrigada.
Obrigado.
Abraço a todos.
Muito obrigada.
Ok, muito obrigado.
Obrigada a todos.
Obrigado a todos também.
Obrigado.
Agradeço imenso a todos pela vossa presença, pela vossa ajuda. Depois vamos conversar isso na próxima reunião da CS9. Muito obrigado também.
Muito obrigado.
Obrigada, boa tarde.
Obrigado, boa tarde.
Obrigado, boa tarde.
Tchau.
Obrigado.